Before we begin, it must be said that the lecture is organized by the online master program Data Science. In this program, you will learn everything you need about working with big data. If you want to learn more, join the chat and channel of this master program. Three minutes and we will start. We're waiting for everybody. Okay, I suppose we can start. Hello, everyone. My name is Tatyana Perevышina. I am a lecturer at the Faculty of Computer Science in the Higher School of Economics. I am Bachelor of Economics and Master of Transport Planning. I worked in the Urban Consulting Laboratory of the university. Today, we will discuss application of data science in the sphere of urban planning and the IT commercial market connected with the city. It seems to me it is important to start with the question, what is DS? It is interdisciplinary science, including computer science, computer science, math and statistics knowledge, and knowledge of the area being studied. Why are all these components significant? Let's imagine you have a task to decrease the level of traffic congestion. In the first case, you are really good in mathematics and also studied advanced methods of machine learning. You can proudly call yourself a ML engineer. But without knowledge about rules of organization of urban traffic, all your complicated ML models will be not viable. I'm not talking about traffic laws. It is more about non-trivial things. For example, building more roads does not reduce traffic jams. Cars occupy all the spaces that is given to them. It's only one thing, but there are a lot of urban paradoxes which are important to know to complete the task. Let's look at the second case. We have the same task, descending traffic congestion. You are also good at mathematics, and moreover, you immersed in all aspects of urban traffic. Undoubtedly, you don't have any skills in computer science. You can't proceed a big amount of information. Result of your work will be theoretical mathematical model, which could be right, but in a limited number of cases for whom it was calculated. In the last case, without statistics or mathematical knowledge, you can create urban research, and but it will be empirical more, and will base more on traditional software such as QGIS. QGIS is a special software for the geospatial analysis, and your work will base only on your experience in the sphere. It can work only if your name has a weight for your client, because it's just a word without any mathematical and theoretical support. Only union of all three components will allow to create a successful and deep project. Okay, now let's answer the question. How did data science begin to be used in the urban sphere? It should be noted that until the beginning of the 21st century, city planners did their job without any technologies. But now we can't imagine how mega cities could have survived without it. There are several reasons why modern cities need data science for management now. The first reason is global automobilization, which started at the beginning of the 20th century. Thanks to Henry Ford, the car became public good, and everybody got the opportunity to have private transport. Automobilization played a crucial role in population mobility. Since private cars became more available, moving from rural areas to cities became less problematic for people. The result is growth of urban population. That leads to the next reason, switching the ideology of urban planning. In the middle of the 20th century, cities began to be car-oriented. 10-lane avenues, multi-level interchanges, low level of pedestrian connection, and weak development of public transport system is the heritage of this policy. Undoubtedly, this approach stopped work by the end of the 20th century. The amount of cars and people in cities was enormous. Planners came to understand that developing a comfortable city is more than cars. People are first. And then a question arose: how we can research and manage such a huge and complicated system as the city? And IT technologies that were already at a fairly advanced level come to the rescue. Do you have any assumptions how many bytes of information are generated daily? Can you write it to the chat? Hello. I can repeat my question. How many bytes of information? It's not about only urban subject. It's about everything. Just your assumption. Okay, I can give some hint for you. Now, roughly speaking, we produce about 2.5 quintillion bytes of information per day. 90% of information in the world was generated in the last 5 years. This massive volume of information is called big data. On the one hand, big data is a source of a huge amount of information for urban planning and business issues. On the other hand, such massive volume of data requires special skills and special software for analyzing it. Moreover, it requires a lot of virtual or physical space for storage. Besides, part of data needs additional protection because it contains private information about users or some insights which companies can use against the company. Firstly, let's discuss open data sources for urban projects. Open data is openly accessible, exploitable, and editable data, which can be shared by anyone for any purpose. Each urban project starts with a state statistical resource. For the planning, we need to know demographic, social, and economical characteristic of the planning area. It includes population amount, population density, level of the income, level of motorization. This main information is stored in the State Service of Statistics. In Russia, the State Statistics Service is called Rosstat. Moreover, large cities have their own open resources for big data. For example, Moscow, Barcelona, and London have official web portals where urban planners can find detailed information about the city, including the number and location of urban facilities and infrastructure facilities. Moreover, as a rule, there are a lot of geo layers which can be used for projects. Sometimes state statistical resources are lacking in some topics. For example, it is difficult to find information about ecological situation in Russia. I don't know why, but it's true. It's really difficult to find something. Then databases of international organizations such as World Bank and Greenpeace, which collect such information, come to the rescue. There are also useful platforms called Kaggle. Machine learning competitions are held there. The goal of the participants is to create a model that will best predict something. Data for models is sometimes provided by huge companies such Yandex, Google, or Facebook. In this connection, it contains unique data sets that can be useful for urban theme. The next source of open data has a crucial importance for urbanists, and the name of this resource is OpenStreetMap or OSM. This is a non-profit project where enthusiasts create probably the most detailed map of cities in the world. OSM has an open API that allows to download all the geodata absolutely free. Thanks to the data provided by OSM, you can analyze a road network, built-up area, and create detailed customized map of any territory. Such maps can be created by special software like QGIS or ArcGIS, or you can create your map in Python, just based on the data which can you download from OpenStreetMap. It is also important for urban planners to ensure transport safety for residents. In Russia, there is a resource that accumulates data of road accident with detailed information and not the least the geoposition of each accident. This data makes it possible to identify and fix the most dangerous section of the roads and reduce the level of road mortality. It is not a secret that the IT market is mainly commercial, and companies have the most detailed data which is not publicly available. For example, mobile operators collect movement data, depersonalize, and sell it absolutely legal in Russia. There are also many companies that deal with navigation system. They record user tracks and use them for personal commercial purposes. For example, Yandex collect information about tracks of user and use it for their profit. Based on the track data, you can create origin destination metrics. The example of origin destination metrics you can see on the slide. This is a main tool of transport analysis, showing population migration through the day. This shows the distribution of population by the area in the morning, afternoon, and evening. Based on this data, cities transport planners create and organize the transport system of the whole city. Based on navigation data collected by companies, it is possible to predict places where traffic jam will occur, and can also be used to redesign the road network. The next paid source of data is a sport mobile application called Strava. When users go for a run, they turn it on and it records the workout track and also calculates the basic characteristic of the workout, for example, pace, distance, speed, and so on. Strava has a publicly available map that shows the accumulated training tracks of people using this application. On the slide, you can see a screenshot of people's training routes in Nizhny Novgorod. The brighter the line, the more people are running along the street. On the one hand, this map allows users to plan their routes or their routes of the run or bike ride. On the other hand, this map gives a huge amount of information for urban planning. However, urban planners cannot download or parse this geodata because Strava closed API of website. But governments or commercial companies can buy the access to the personalized tracks of users for their own aims. It can be commercial aims or social aims. But if you are an independent planner working on non-profit project, Strava can provide this information for free. We discussed the main sources of geo information and information for the urban project. There are two main groups, open data and closed data. Open data you can download for free, and closed data you need to buy. And sometimes it can be really expensive for the purchasing. Maybe you have any question about the sources of big data, and maybe you have some question about closed and open data. You can write it to the chat. Not billions, Anna, quintillions, there are a lot. Okay. Maybe. Okay, if you haven't got any question about the sources of open data for the data for the urban project, we can move to our next topic, is smart cities. Now the internet, mobile apps, street cameras, and sharing technologies generate a huge amount of data which is used for urban management and commercial purposes. And data science helps to analyze city process hidden in big data generated by everybody. Cities that have an integrative IT management system are called smart cities. It includes the Internet of Things, open data, smart mobility, smart government, smart energy, smart home. All these components led to efficient management and convenient space for the modern citizen. Smart cities can be called London, Singapore, Beijing, Moscow, New York, Barcelona. All the cities have complex IT systems that are implemented in all areas of life. Take a closer look at the technologies used in smart cities. Undoubtedly, data science made a mobility revolution. Sharing technologies of the modern cities are huge commercial IT market. Uber and Yandex changed patterns of transport behavior. Also, it made taxi trips safer for customers. Moreover, price is based on actual demand, which is calculated on the amount of free drivers and the amount of customers requesting the car in the specific area. Car sharing technologies also shifted attitude to the possession of private transport. Car sharing is a type of short-term car rental with per-minute pricing. It is usually used for short intercity trips, and the rental takes place through the mobile application. The opportunity to use the car all the time without additional only cost, just mobile apps, gives a lot of benefits for citizens, especially in condition of limited parking spaces. The next technology is ride sharing or carpooling, have recently become widespread in Russia. Carpooling is terms means joint travel. The idea of this service is that to save fuel and money, people can team up for long distance trip. In Russia, the BlaBlaCar application is actively used for this, where people can find the ride into the required direction. In addition to commercial sharing technologies, DS is actively used in managed transport demand. Sensors and road cameras record information about the transport load and number of free parking spaces. This information is analyzed on source, and then, for example, the price of parking or price of travel through the tunnel is calculated. And the user can evaluate the economical feasibility of using private transport in the current moment. It goes without saying that people's transport behavior has been influenced by maps showing traffic congestion in real time. Such companies as TomTom and Yandex collect data from each user, accumulate it, and perform the dynamic road situation. Also, this technology gives an opportunity to choose the optimal road and mode of transportation. The next technology is related to artificial intelligence and called computer vision. Computer vision is an AI service that enables computers and systems to extract meaningful information from digital photos, videos, and other visual inputs, and to conduct actions or provide recommendations based on that information. This technology is often used for payment of public transport. For example, in the Moscow metro, it is not necessary to buy a transport card to pay for travel. Cameras at the turnstile read your face and debit the travel amount from your transport account. Computer vision technology is also core of self-driving cars. Built-in system analyze the current traffic situation. Car itself navigate the city by analyzing information around. So far, some legal issues regarding the use of computer vision, such as those related to self-driving cars, are underdeveloping in most countries. But I think in 5 years, they will become part of the norm. Computer vision is used to track violators of traffic rules and offenses. Let's discuss a little how computer vision technology is implemented, for example, detecting a pedestrian crossing the road in the wrong place. First, a model is created that is trained on a large amount of data. What is this data? For example, 1 million videos are stored there. In some of them, people cross the road according to the rule, but in others they do not. And these videos are marked so that the model understands where the violators and where they are not. After that, model has trained and understood how visually distinguish violators from non-violators. And after that, it can be used in practice. We discussed the main technologies which implemented in the modern cities, and which technologies are the part of smart cities. Maybe you have any question about any technology, I can answer you. Just write to the chat. Part about itself. I can wait a little. Okay, maybe we discuss sources of big data. We discuss technology which implemented in smart cities. One more technology is Google Earth Engine. It's a special software. I can demonstrate you how it works. But it's Google Earth. It's not a source of big data. You can analyze visually any territory. It's a Google Earth. how it works. It is really a detailed map of each word from the space. For example, Chelyabinsk. You can visually asset some information from the city, but you can't download information from this map. And it's why I didn't add information about Google Earth in my presentation. It is more detailed than, for example, Yandex Map or Google Map. Something like that. Earth engine with JavaScript. Yeah, but yes, of course you can parse information with JavaScript. I'm not really sure. I haven't got skills in JavaScript. When I need some JavaScript skills, I go to the engineers, and they can find it for me. But I suppose it seems to me you can't parse information from Google Earth with JavaScript. Maybe I'm not really immersed in this. For me, the main source of information of geodata is OpenStreetMap. I suppose you see my screen. I can show you how it looks like. OpenStreetMap. It's a public card where you can sign in, and you can create your own layers of this map, and you can find any roads, any layers with any build here of each city of the world. If you want to download this information without any additional plugins, just select areas and after that push on export. Okay. Now let's solve real cases of urban planners. And our first case is a car sharing company. Let's imagine you work in consulting companies that deals with urban projects, and a car sharing company comes to you as a client. They want to increase the coverage area of its service in the city. Now car sharing operates only 20% of territory. For now, they haven't got enough resources to cover the entire city, but they want to identify areas that are the most profitable for them. Your task is to determine which urban areas the company should expand into in order to increase its profit. We have a scheme of our city. A gray zone is a city area, orange zone is a service area of the car sharing, and we need to expand it. Do you understand the task? No, right, wonderful. The first question, in which data we need to request from our client. For example, car sharing service provides us data sets with a number of orders in each point of coverage area in rush hour on some weekdays. You can see a sample of this data set on the slide. For each point, we have longitude and latitude, a number of rents in the separate coordinate. For example, for the first point, we have 12 rents per hour. And our client data set has a millions of points for each coordinate of the coverage area. The second question, which data can characterize the urban environment in which of this information can be found in open sources? In the official portals, we can find geo information about number of population and workplace in each area of the city. Also, from the OpenStreetMap, we can parse the locations of points. Points are points of interest. There are places of attractions such as restaurants, shops, museum, parks, any place which can be interested for the people, for the person. Sorry. Also, OpenStreetMap provides geodata about roads and parking spaces. Thanks to this information, we can calculate the density of the roads and provision of parking spaces in each area of the city. Don't forget about public transport. We will also download data of the location of public transport stops and metro stations from OpenStreetMap or from city web portals. Moreover, each municipal unit is required to maintain a register of public transport routes with a detailed description of each road. There are main information from the open sources. Can you imagine any other characteristic of urban environment which can be available for free and which can be used for our project for the description any urban area? We have population, we have information about the road, information about public transport stops and metro station. Yeah, we have already downloaded information about POIs. POIs are restaurants, parks, museum, and so on. There are also POIs and restaurants too. Maybe something more, if you have any assumptions. Sorry, I can't simultaneously look to the chat and demonstrate my presentation. Okay, I suppose it's enough information for our analysis. Let's move to the next step. If we have a budget, we can buy any commercial data. For example, we can buy tracks of mobile operators for understanding the intensity of pedestrian activity in the area or for creating origin destination metrics. If we want to include data on last mile transport in our model, we will buy data from Strava. Last mile transport is an expression that includes scooters, bicycle, longboards, any non-motorized type of transport, and we can buy it from Strava in Strava. It would also be useful to acquire data on the movement of cars in the city. This is necessary to assess traffic intensity and the traffic load of roads in each area. We get information from the client with the amount of rents in each point. We found main information from the open sources, and maybe we bought information from commercial companies. Now we are ready to generalize this information and connect this information with territory. Urbanists use the following approach. The city is divided into hexagons. This is one hexagon. And with an area of 1 square kilometer or less. It is also possible to divide the city into squares, but hexagons are considered the most optimal form of division. And for each hexagon, we accumulate our indicators. In our research, the hexagon is a unit of observation. To begin with, we calculate the indicators for the service area. The first column is the volume of demand. This is the total number of rents within one hexagon. We will also calculate the population size for each hexagon, number of boys, number of working places in each hexagon, the density of roads, level of public transport availability, and all others characteristics which we collected on the previous step. But on this step, we generalize this information for one hexagon, for one area of the city. The next step, we need to divide into hexagon non-service area and generalize the same factors for this non-cover territory. We haven't got the demand indicator because it's our task to predict the level of the demand for new zones. And then we have two data sets. One data set for non-service area characteristic, and the second data set with service area. And in the data set with service area, we have a demand column. And then we are faced with a question: which machine learning methods will be chosen to predict demand level for the non-service area? And probably the most obvious option is to build a regression model. The task of any regression model is to predict some real value. The first step is to create a regression equation. On the left side of the equation, we have a factor that we predict. In our case, this is a number of rents, that is a demand. On the other side of regression, there will be the factors that we have collect. That is what we can influence. What can influence demand? It's population, number of boys, number of working places, road density, and so on. First step: creating a regression equation. The second step is to train the model. To train a model means to find the values of this coefficient, W0, W1, W2, and so on. And the coefficient the coefficient of each factor indicates the degree of influence on demand. How learning occurs? We take data of service territory and use the ordinal least square method to find the values of this coefficient from our data. We have a special formulas for the finding this coefficient. If you will learn the methods of regression analysis, you will learn these formulas. After we trained the model and found the coefficient of our model, W0, W1, and so on, we will check the quality of our model, and if it's good, we make a prediction using data from unserved area. That is, we substitute the value from each column into our equation and find the demand value for each hexagon. For example, we have one hexagon with the prediction demand level 221. The second hexagon has the predicted demand value 123, and so on. And we have this value for each hexagon of our uncovered area. Do you have any question about regression analysis? Is it a random choice of choosing as a coefficient initially? No, we have a special formulas for calculating the value of each coefficient. It's not a random choice. It's a mathematical approach to the finding it. But our lecture is more science pop, and I just talking about the concept of the model. Okay. It was our first approach by regression analysis. But what if the problem is formulated differently? We don't want to predict the specific value of demand for each zone, but rather there will be low, average, and high demand. Then we already solve the classification problem, and our model should predict the group of the demand for each hexagon for non-served areas. Firstly, we need to record the demand factor and determine each observation into low, middle, and high level of the demand. Let's look at this sample. This sample of the data. One is the low level of the demand. Second is average level of the demand, and third is the high level of the demand. After we record the demand column and fold each hexagon into the group with low, average, and high demand, we can create a classification equation. On the one side of the equation, we place what we want to predict. In this example, it is a category of the demand, which only takes three values: 1, 2, or 3: low, average, and high. On the other side, all factors of the urban environment: population, number of working places, every factor that we have already collected before. Furthermore, we need to train our model on surface area hexagons and calculate values of the coefficient of our classification model. In classification analysis, we use other methods of finding coefficient and use other formulas for calculating W0, W1, and so on. After training and checking the quality of the model, demand prediction can be made in hexagons of unserved areas. And our model will determine each zone into one of three groups according to the level of the demand. Even in the previous example, the model determined the actual value of demand. We have a number of rents per hour. In classification analysis, determine the group into which the observation falls. For example, the first hexagon fall into the group 2. This is a group with the average level of the demand. The second hexagon is also in the average in the group with the average level of the demand. But third hexagon fall into the first group with the low level of the demand. Regression analysis predict real values. Classification analysis fall observation into specific group. It is the main difference between these two approaches. Do you have any question about classification analysis? Clear. Wonderful. And the last approach is ranking. You can use it for if you want to order hexagons by level of forecast demand. First, you will need to assign number to each service area's hexagon depending on the size of the demand. The hexagon with the greatest demand will have the number 1, and the hexagon with the smallest demand will have the largest number. After that, we make an equation ranking model. By this model, we want to predict the rank of each hexagon on the basis of factors of the urban environment. Furthermore, we need to train our model and surface area hexagon on surface area hexagons and calculate values of the coefficient of this model. Again, W0, W1, and W2. But again, we use other formulas for the calculating because we have different approach to our task. And our last step is to predict the rank of non-surface area hexagons. The result of the model is a new column with the rank. The lower the rank, the greater the demand of this territory. For example, the hexagon the hexagon 2 has rank 2. This is it means that we have a hexagon with a high level of the demand, but hexagon 1 and 3 has low level of the demand, because they are on the end of the list. Questions? No, makes sense. Wonderful. Okay, we learned three approaches for solve this task. The first approach is regression analysis, when we want to predict a real value of the demand in each hexagon of the non-coverage area. The second approach is classification analysis, when we want to fall hexagons into one of three groups with low, average, and a high level of the demand. And the last approach is ranking, when we want order our hexagons from the most profitable to less profitable by the ranking model. And now we need to move to the last case of our meeting. The last case is urban policy. Suppose you work in the city transport department. You have been given to the task of developing 5 options for the city's transport policy. Transport policy options should be designed depending on 2 indicators: the number of parking spaces in the area and the distance to the metro station. Again, we need to divide our cities by hexagons. And for each hexagon, we generalize information about the number of parking spaces and average distance to the nearest metro station. And then we are faced with the task of dividing these hexagons depending on the availability of public transport and the number of parking spaces. When we need to solve the problem of dividing objects into groups depending on their similarity, we solve the clustering problem. One of the simplest approaches to clustering is the K-means method. How does it work? Let's place each hexagon on a coordinate axis, where the x-axis is the distance to the metro, and y-axis is the number of parking spaces, and crosses are our hexagons. For example, this cross is a hexagon in which there is a low provision of parking, but it's closer to the metro. And this is a hexagon which is far from the metro, but there are many parking spaces there. And now we need to divide all these objects into 5 clusters based on their similarity. Similarity will be determined based on Euclidean distance. The K-means method will consider different combinations of clusters and select the combination in which the average distance between the object in one cluster will be minimal. As a result, we will get 5 zones. Red zones with a high supply of parking spaces and the proximity to the metro. Green areas of the territory with a low provision of parking spaces, but proximity to the metro. Gray areas, average provision of parking spaces and average metro access. Yellow zone have a high supply of parking spaces, but are far from metro. Orange zones, low ability of parking spaces and far from the metro. A different policy can be recommended for each cluster. For example, for red and yellow zone, increase number of bus routes since the metro is far away from them. Green, gray, and orange zone territories are recommended to build a bicycle path, since there is no space for storing personal vehicles. And the gray and orange zone ones are also far from the metro, and we also can recommend create more bicycle paths or create new roads of the bus or troll. Do you have any question about cluster analysis? We define the cluster based on the similarity. Similarity is defined by Euclidean distance, and after that we can make different recommendations for different groups of hexagon for different territories, for different areas of the city. That's all I want to tell you. If you have any question, you can ask them to the chat. We discuss smart cities. We discuss source of big data. We solve two case using regression analysis, clustering analysis, ranking analysis, and clusterization. I'm really happy that you are amazed by clustering. Not Euclidean. Yeah, of course, we can use different methods of calculating the destination, but the most obvious and convenient Euclidean one. And Kamin's method used Kamin's used Euclidean, as I know. What about modeling the city landmark as nodes and the road of addresses solved via graph models? Yeah, graph analysis is also used for the transport planning, but every program which use modeling, if to be honest, they are really far from the reality. The most of the model and program which created the model of the city was created at the beginning of the 21st century, 10 years ago, and they can't create the real picture of the movement of transport in the city, because I'm not really big fan of the modulation city in how it works now. Maybe do you know some cases where ML used in urban development sphere for X buildings and etc.? Okay. For example, you're working in the development of building, and you need to find the new territory for the new building. You may analyze territory by hexagons and can predict the number of people and the characteristics of the territory, and can find the most optimal place for the new construction, again using ML models. You can use again a regression analysis, for example. I was also thinking about the time series analysis, trends and patterns. At MPM, there is a spike in the afternoon, no spikes at all. Sorry, I'm not trends of patterns. Historical analysis, time series analysis is not really useful in urban management, because for us as urban planners, we need to analyze situation now, but we can predict something like predict the number predict the number of predict the level of traffic congestion, for example. But I suppose we don't use ARIMA or something like that for the analysis. It's more about neural networks analysis. Time series is too easy for predicting the traffic jams or something like this. Maybe for the research it can be maybe if you are just a researcher and you want to analyze something from the past, it can be useful. But in the real life, for the prediction some traffic congestion, people use as a rule some artificial intelligence, something like that. Well, you share the slideshows displayed. Yeah, I sent this information to this master program, and they share this information with you. Could you show your mail if you are that question would appear, of course, if you're okay with it? Yeah, okay, I can write it in chat. 1 second. I wrote my email address to the chat. If you have any question, you can answer it. Could you please recommend some books about urban planning? It is difficult for me to recommend something because my path to the urban sphere was in academic sphere, but I may found something, and I can send it to the chat of the master program, and I can recommend something about this. I can show you my favorite book about transport planning. 1 second, I have one. One second. I can show something. It's my favorite book about transport planning. It's a book of Donald Shoup. He is a scientist from Los Angeles, and he is a mastodon of parking policy. This book about how parking inefficient in the city, and its influence on the traffic behavior and traffic congestion in the cities. I really recommend this book. It's my favorite one. Donald Shoup. In English, it's called High Cost of Parking. In Russia, высокая стоимость платной парковки. I'm not sure that you can buy it now in Russia, but it's really interesting. Maybe you can find any free copies in internet. Okay, yes, if you haven't got any question, we can stop. Thanks for your attention. I can send the list of urban books in chat later. Bye-bye.